Let's have a look at graphing lines from equations, and there's two forms for us to look at. The first version of writing a linear equation is the slope-intercept form, or the mx plus c is what we call it, and that's what we just talked about in our last video, where m is the slope and c is the y-intercept. The other form is called general form, and it's in this version here. They've each got uses in different ways, but essentially they're the same line though, they're just written in different ways. I find this one in some ways the easiest to use because of graphics calculators, because that's the format that you need it in. But this particular form is handy when you have other points like the x and the y intercept, and then that's easier to work out in some ways. So let's look at each of those. We've talked a lot about this form already, so we'll just do a little bit of a recap, won't spend long on it. If you need to draw a graph in this form, this slope-intercept form, you need a point and a slope. And the point, the easiest one, is the y-intercept, which comes from that c value. And to use that, the x value at the y-intercept is 0, because the y-intercept is where the graph cuts through the y-axis, and so the x value at that point is 0. So you use that c value to graph. So if the c value is 9, you would put the dot 9 up on the y-axis. And then for the slope, it's the rise over run, is what we've already been talking about before, or the y2 take y1 over x2 take x1. We then use 2 points to connect them using that slope. Let me show you on the... So if you are asked to graph the line of y is equal to 3 over 2x take 4, where do you start? Now, I appreciate that I've got the whole answer written here for you. Let me try and talk you through it. Starting with the y-intercept, so you would draw up a grid to start with your x and y axes. Start with your y-intercept, -4. So going down -4 and putting a dot. Hence, we've got the dot on the graph here at -4. And then you use the gradient. So 3 over 2 means we're rising up 3 and running across 2 from that dot. You can put the rise on the left or the right from this dot, so you're going up 3 spaces and running across 2. Put another dot, then connect the dots using a ruler, because then that 3 over 2, the rise and run 3 over 2 has to continue all the way up that line, putting arrows on your line to say that it continues, labeling the line with its title there, the y equals value, and that's what you do. Just a reminder that if you don't have a fraction, how do you do the rise and run? If you had a graph of y is equal to 2x minus 4, the y-intercept is again -4, but how much do you rise and how much do you run? Just a reminder that every whole number is actually the same as putting it over 1, because 2 divided by 1 is still 2, but that will help you to remember, we rise up 2 and run across 1. Likewise, if you had y is equal to -3x take 4, y-intercept is still -4, but you might find it easier to put these numbers over 1. This time it would be a downhill of 3 and across 1. So rising down or falling down of 3 and across 1. So that's a little technique for that one. And when you have to do it in general form, here's some reminders here. It's ax plus by is equal to c. The two steps are find the y-intercept and the x-intercept. When we find the y-intercept, you put the opposite letter is equal to 0, as you can see. X is equal to 0. When you find the x-intercept, put the other letter equal to 0 and solve. Let's do some practice at that. Once you've got the values, you mark them on your graph, connect them with a ruler and continue the line out, and then you've drawn the line. So if we're asked to draw the graph of 3x plus 5y is equal to 15, what do you do? Now, I know you can see the answer sitting right here already. Here's the technique. You write x-intercept, therefore y is equal to 0. And the other step we're going to do is the y-intercept, therefore x is equal to 0. It doesn't matter which one you do first. When y is equal to 0, let's substitute that into the equation. I'll do it showing you all the steps the first time round, but you can notice that this parts will disappear. Where I saw a y, I substituted in the number 0. So what happens to this section here? This 5 multiplied by 0, that's going to disappear, as in it's going to be 0. So technically it's now 3x plus 0 is equal to 15, which we didn't really even need to write. We could have just written 3x is equal to 15. Then solving for x, we need to divide through by 3. So 15 divided by 3 gives us 5. As you can see on the graph, that matches up. That's the x-intercept, so you put a dot when x is equal to 5. Could we have done that a bit quicker? Having a look here, this 3x plus 5y is equal to 15. If we know that when we put the 0 in, that part's going to disappear, we could have just moved straight to 3x is equal to 15. Hope you can see that with me. Let's apply that then to the y. If we're going to substitute in then when x is equal to 0, start to imagine what happens to that term. When x is equal, it's 3 multiplied by 0, it's going to become 0, so we don't really need to write it. So let's write what's left over, which is 5y is equal to 15, dividing through by 5 gives us 3. So the y-intercept is 3, so on the y-axis you put a dot at 3, and then you connect the line, making sure you've put arrows on the end to extend the line out, and you label the line with its title, which is the 3x plus 5y is equal to 15. So that's how we graph from the general form here, and the other one is the slope-intercept form. There are the questions to do. Subscribe to the channel. Thanks for joining me.